Hey boys and girls, we're going to continue along with the electron arrangement stuff today and actually look at the electron configuration orbital diagrams, which is one of your honors editions, or actually your honors edition for this unit. Okay, probably one of the more challenging things that we're going to do this semester because a lot of it is very, very conceptual and less memorization. Anyhow, you hopefully remember that electrons are going to occupy the very lowest energy level first. Okay, and that each different level has different amounts of electrons it can hold. Well, the first level can hold 2, the second level can hold 8, the third level can hold 18, and the fourth level can hold 32 electrons. A lot of this occurs, though, because these levels, the second orbital level, actually has sub-levels. Okay, and this third one with the 18 has a couple sub-levels, and this 32 has a couple sub-levels. So what we're going to do is we're going to look at how the sub-levels actually interact. Before we get into that, what exactly is an orbital? So suppose you had a singular hydrogen atom, and knowing that singular hydrogen atom, you very likely have one electron. That electron is moving around very sporadically and randomly and very not in a structured format. Okay? And if you went through and you every 2 seconds kind of plotted where it was around the given nucleus, kind of like we see up here, if you did this 100, 1,000, 2,000 times, you're going to get a weird spattering graph like this, or a weird spattering picture. Notice that there is not a singular rigid circle, but more a region where there is a very set dense area where the electron is likely to be found. Okay? So right here, this is an orbital of where we are most likely to find our electron. And notice it's going to go through, and the further you get out from the nucleus, the less likely you are to find that electron. The closer you are, there's this nice little band where it's very, very dense, and we have a very good probability of finding an electron in there. But again, it's not traveling on a set path. Okay? It's very whimsically all over the place. Okay? So an orbital basically means that the electron can be found within that general location 99% of the time. It is not a specific orbit. No on the orbit. We call those orbitals. Okay? And as we go through and get into multiple orbitals, the same idea occurs. It's just that there happens to be a gap, as you see right here, between what is the first orbital, and this would be the first, and this guy on the outside is going to be the second orbital. So the second orbital kind of spans from here to here, and you'll get a little bit of outliers on the outside. Your first orbital is spanning from here to here. And you notice that there's a gap in the middle that you generally don't find electrons in. Okay? So all an orbital really is a general region where we are likely to find electrons because they do not orbit. They do not follow a very predictable elliptical path. Instead, they again are randomly traveling around, but in a predictable general region. Okay? Hopefully that makes sense. If it doesn't, we'll talk about that a little more in class. But moving on, basically each different orbital has a set shape, or every suborbital has a different set shape. Okay, we're not really going to deal with the shape so much. That's something you're going to worry about later in chemistry courses. But all you really need to know is that each different shape gets slightly more and more complicated. And the reason that this happens is because electrons are negatively charged and they're attracted to protons. So they want to get pulled into the nucleus as much as possible. Problem is other electrons are negatively charged, and they want to stay away from those other negatively charged things. So the idea of the different shapes is to try to get as many electrons as close to the nucleus as possible while keeping those electrons as far away from each other as possible. Okay? So the shapes are things that if you understand this conceptually, they'll probably help you out a lot, but if not, it's something that we won't deal with as much in this course. Okay? What we're going to do is we're going to learn the basic ins and outs of the electron configuration, so we can figure out how many electrons are in each suborbital, and we basically have 4 different types of suborbitals. Remember that we have 4 different energy level orbitals, one that's got a 2, one that's got an 8, one that's got an 18, one that's got 32, but within a couple of these different energy levels, there are suborbitals. And our suborbitals are the s, the p, the d, and the f. And you really don't even need to know about the d or the f orbitals because we're not going to deal with those. We're going to stick primarily with our s suborbital, which holds 2 electrons, and our p orbital, which holds 6 electrons. And if you wanted to kick it back, that basically means that the shapes that these orbitals take up is you kind of have this nice little figure 8 here, and you've got 2 little figure 8s next to each other here. If we're talking about the S is the singular circle, the P is going to be your first figure 8, the D is even more complicated than what we're going to get into. Okay? So anyways, how do we remember all of that? Well, we've got a couple of different tricks that should be able to help us out. Okay? Realistically, the periodic table is set up to tell you absolutely everything that you need to know and walk you through what's going on. So if you look at your periodic table, you're going to notice that at the left side there's going to be a 1, okay? Even to the left of the alkali metals. Well, that's basically your 1s group, okay? So this is 1s and this is 1s. Now within the 1s block, as you remember, our s block only holds 2 electrons, okay? So this s block right here is holding our first electron, so I get 1 electron here, and I get 1 electron here, okay? And then my s block is filled up, and I need to move on to my next block. And you remember, if we go back and look, that this level happens to have, we got 2 in the first, and the next one's got 8 in it. Well, when we look at those 8, 2 of them happen to come in the form of an s block, and the other 6 come in the form of a p block. And you fill up those 8, and we kick our way down to the 3s block. And we fill up those, and we'll then fill up the 3p block. Okay? So maybe this doesn't make as much sense. Well, let's kind of try this guy out. All right? Every single individual element has a given number of, or a given orbital diagram based on what specific electrons it's holding. Okay? So if we look at our first one, we have 1 electron in the 1s orbital. Okay, so if I was to go through and I was going to say, hey, hydrogen, what's the orbital diagram? It just happens to be 1s1. If I was going to go through and say, hey, helium, we know that that's got 2 electrons. Well, in the 1s diagram, or the 1s orbital, we happen to have 2 electrons. So that's going to be a 1s2. If I got myself down here to lithium, however, so Li, I know that I've got 3 electrons. Well, those 3 electrons, basically I got to go through and I got to tell you everywhere I've been. I got to show you every block that's full. And we filled our 1s block, so 1s2, because the 1s is completely full, so that's full and that's full. And we now have something in the 2s block, but how many do we have in the 2s block? We have 1 electron. Okay? And the cool thing about these is if you add up the numbers, it shows you how many electrons we have. So that's 1 electron. That means we have 2 electrons. And this guy means that we have 3 electrons. And you're basically going through and listing out every single block, or every suborbital, how many electrons are in that one. So if we go through and we look at, for instance, get really crazy here, all the way down to this guy. If you look at the 3st and then compare it to your periodic table, that guy's going to be magnesium. And if you remember, that's got 12 electrons. Okay? So let's try this guy out. I've got 1s completely full. Alright, so 1s2, I got 2 electrons in that 1s block. I then go through and I have the 2s block completely full, so 2s2. So that's done and that's done. My 2p block is completely full. Okay? So I fill that up, 2p6. And then I go through and I've got my 3s block completely full. So that's going to be 3s2. And if you add those up, 2 plus 2 gives us 4, plus 6 gives us 10, plus 2 gives us 12. And that's our double check there. Okay? So your orbital diagram for something like magnesium is going to look like that. If I happen to have, instead of magnesium, if I used sodium, It's the exact same thing, except we've got one less electron in the 3s block. So it's going to go through and you've still got your 1s block full at 1s2. You've got your 2s block full at 2s2. You've got your 2p block at 2p6. And we've gotten all the way down here, but we're stopping here at 3s1. And so hopefully that goes through and at least gives you an idea of what we're doing with orbital diagrams. But all this is really saying is, where are my electrons most likely to be found around these given atoms? And the reason that we go through, and I showed the previous picture, we're never going to go past argon here at 3p6. Okay, so you don't have to worry about anything below this. You'll worry about those in later chemistry classes. Okay. Moving on a little more, we got a second trick where if you actually write out all the 1s's, the 2p's, the 3d's, and then the f's, you can actually kind of give yourselves little arrows to follow along the whole way. And we'll talk about that a little bit later in class. But I find that if you just follow the periodic table, generally you're pretty darn good with what you're doing. And a third trick, if you kind of understand the energy level table, where you start off with the 1s, and then the 2s's, and then 2p's, and then 3s's, and the 3p's, and after the 3p's, 4s's, and 3d's, and 4p's. And we'll talk about this guy in class as well. Alright, so the electron configuration, we kind of already talked about this, but the idea here is that this very first number is just telling you the energy level we have. This second guy is telling us the type of orbital we have, and this superscript is just telling us how many electrons are in that orbital. Okay, and the highest thing that we can get up to is argon at 1s2, 2s2, 2p6, 3s2, 3p6. And if you're at this point and still kind of confused, I would kick back a couple minutes in the video and look at what we did while we had the entire periodic table out. Okay. So trying out a few, we've got beryllium, we've got oxygen, we've got phosphorus. First thing I would do is figure out how many electrons we have. This guy's got 4. And knowing that I've got 4, I'm basically going to start off 4 electrons. I fill my 1s diagram, or orbital, with 2 electrons. And then 2s gets 2 electrons. Oxygen is going to go through and get itself at, what do we got? 8. So we've got 8 electrons. And so you're going to end up getting, at 8, you've got 1s2. You've got 2s2, and that means I've got 4 electrons left. So in the 2p block, I'm going to have 4. Okay? And phosphorus, you should go through and get the similar thing all the way up to, being that phosphorus has, well, we've got 15 electrons. You count them all up, 2, 4, 10, 12, and 15. Okay? And again, if we need to work on this, we can kind of talk about these in class. Okay? Kicking through, basically, orbital diagrams are showing the spin of the electrons in those given orbitals, okay? Because 2 electrons in the same orbital are going to spin in opposite directions. And what that means for this is that we're going to go through and we're going to fill every single orbital with arrows that are either up or down to represent opposite spin. Okay? And so your rules here is that you must fill one complete orbital before you move on to the next. So I need to fill up 1s all the way to 2 before I can move on to 2s. Okay? And I need to fill 2s before I can move on to 2p. And I need to fill all of 2p before I can move on to 3s. And that'll make sense once we get through and hit one of these guys. Alright? This second part, so we fill up the 1s, we basically go through, fill up the 1s here. Alright, so for helium, up and down. Alright? For something like carbon, where we've got 6 electrons, you've got to fill the 1s with an up and then a down before you can move on to the 2s. At 2s, you fill it with a 1 up and a 1 down. And then once you get to 2p, we need to have 3 up arrows before you come back and produce a singular down arrow. Okay? And so if we go through and we kind of practice this guy out, or look at this guy, this is how your 2p block should look if you only have 6 electrons. This is incorrect. You will not have them double up until every single electron, or every single portion of that orbital, happens to have at least 1 up arrow in it. Okay, and we'll hopefully practice those a little bit more in class. If you got any questions, we can talk about those. But that at least gives you a basic idea of what's going on for your orbital diagrams.